All right, we're going to continue here in section 8 by looking at a very important expression in pre-calculus and calculus known as the difference quotient expression. And it comes straight from the slope formula, which I have written out here. I've drawn a curve, y equals f of x, and I have 2 points on the curve, x sub 1, f of x sub 1 right there, x sub 2, f of x sub 2 right here. And I've drawn the secant line here in red that goes through those 2 points. Now, if I look here at x sub 1 and x sub 2, and I say that the difference between these two values is h, that would mean that x sub 2 would be equal to x sub 1 plus h, which I have written here. So if I replace the x sub 2's with x sub 1 plus h, I have this expression. So if I do that over here, replacing the x sub 2's with x sub 1 plus x sub h, x sub 1 plus h, I get this expression, and you can see that the denominator, the x sub 1's cancel, and that leaves this guy. Now, normally we just drop the 1's here, the subscript 1, and we write the difference quotient expression as f of x plus h minus f of x all over h. Now, I'm going to try some examples here, and f of x is equal to 4x minus 2, find f of x plus h. Well, notice I've underlined this because I'm not plugging in a number, I'm plugging this whole expression in right there for x. So that's going to give me 4 times the quantity x plus h minus 2, or better yet, 4x plus 4h minus 2. And the reason that we do that is because that's the first part of the difference quotient, which is the second part of this problem. Find the difference quotient expression, f of x plus h minus f of x over h. So using this function right here, now, by the way, this is the equation of a line that has slope 4, and we're finding the secant, the slope of the secant line. Well, if there are 2 points on the line, the secant line is going to be the same as the line. I'll bet you a quarter here that this is going to turn out to be 4, but we'll see what happens here. F of x plus h we have already, that's this guy right here, that's 4x plus 4h minus 2, minus f of x, which we also have, that's the quantity 4x minus 2, and that's all over h. So that's 4x plus 4h minus 2 minus 4x plus 2 all over h. You can see what happens here. It simplifies. I have like terms that cancel out here and here. So this equals 4h divided by h, and you can cancel the factors of h there, and I get 4, which is what I expected it to be. You can pay me a quarter later. Now, for this next 3-part example, I'm going to do the difference quotient, but I circled it here in red, which means that these are the problems that you'll see on your semester exam review, which is a pretty good indication you're going to have at least one of these on your semester exam. So I'm going to write these out, and I'm going to do quite a bit of simplifying, and so you have to be really careful with your algebra, because it does say to simplify here. So f of x is equal to 4x squared minus 6x plus h. The difference quotient would be f of x plus h, so I'm plugging in x plus h in here and here. And then I'm subtracting from that f of x, which is all of this, and that's all over h. Well, that numerator, I'm going to have to multiply some stuff out there, and hopefully I can squeeze this all in. I'm going to go ahead and do 2 steps. I'm going to square this binomial and distribute by 4. This would be x squared plus 2xh plus h squared if I squared it, so I'm going to have 4x squared plus 8xh plus 4h squared. I have to distribute here. Minus 6x minus 6h plus 1. And then I have to distribute here by a negative 1. So that's going to be minus 4x squared plus 6x minus 1. And that's all over h. Well, something really nice happens here. This thing simplifies because I have some like terms here. I have 4x squared and a minus 4x squared, they cancel. I have a minus 6x and a plus 6x, they cancel. And I have a plus 1 and a minus 1, and they cancel. And notice, everything that canceled on the top didn't have a factor of h. All that remains are these 3 terms, and they all have at least one factor of h, which I'm going to factor out. I'll factor out the h here. That leaves 8x plus 4h minus 6 all over h, and that gives you 8x plus 4h minus 6, and that's what it simplifies down to. Now, After you do a few of these, you'll notice that you can do the arithmetic a little faster and you'll see patterns. But when you're first doing these take a few steps. This one included, because I'm going to simplify this expression even where it doesn't look like it needs to be simplified. F of x is equal to x, the square root of x minus 9. So I go to this guy. This is going to give me the square root of x plus h minus 9. Notice how I plugged x plus h in for x. Okay, and then I'm going to subtract from that f of x, which is the square root of x minus 9, and that's all over h. Now, upon first appearance, you'd say, well, you're done. You can't simplify that, and you're right. The numerator, these are not like radicals, so I can't combine those. But I can do something with it that's going to seem a little odd. I'm going to multiply the numerator and the denominator by the conjugate of this numerator, which would be the square root of x plus h minus 9 plus the square root of x minus 9. And I'm going to multiply top and bottom by that. The idea of the conjugate is to eliminate the radicals in the numerator when I multiply. Normally we rationalize the denominator. I'm actually rationalizing the numerator, kind of weird. And in this case, FOIL becomes first and last because the outer and inner cancel. So when I multiply these guys, I just get the expression x plus h minus 9 minus, when I multiply the last, I get minus 9, the quantity x minus 9 here. And that's all going to be over. Now my denominator's gotten quite a bit more cumbersome. And I know that you're not typically to leave radicals in the denominator, but we're going to in this case. You may also notice that my numerator will simplify because when I distribute here, I'm going to get x plus h minus 9 minus x plus 9, and that's all over h times the quantity of the square root of x plus h minus 9 plus the square root of x minus 9. And you can see that the x's cancel, the 9's cancel, and I'm left with a single factor of h. And I have a factor of h in the bottom, which is one of the reasons why I didn't distribute. So these cancel out, and if I can squeeze this in, I'll put it right here. This would be 1 all over the square root of x plus h minus 9 plus the square root of x minus 9. And I know it may seem weird because I left radicals in the denominator, but that's what I would simplify that down to. You'll see the reason why when we get to calculus. This last one here, I have a rational expression, so I'm going to have to be working with some denominators here. My difference quotient would be x plus h in here and here, 3 times the quantity x plus h minus 5, all over 2 times the quantity x plus h plus 7. That's f of x plus h minus f of x, and that's all over h. So I'm going to have to multiply top and bottom to get rid of those fractions. But before I do, I think I'll distribute here really quickly. So that's going to give me 3x plus 3h minus 5 all over 2x plus 2h plus 7 minus the quantity, let's see, 3x minus 5 on top, 2x plus 7 on the bottom, and that's all over h. Now what I want to do here, and it's going to seem kind of messy, is I'm going to get rid of the complex rational expression by multiplying top and bottom by these two polynomials, the product of these two polynomials. So 2x plus 7 times 2x plus 2h plus 7 on top, 2x plus 7 times quantity 2x plus 2h plus 7 on the bottom. I like putting the binomial before the trinomial when I can. And I'm going to multiply, and we'll see what this gives me. Now here I have to distribute up top. So when I multiply these guys, these are going to cancel, and I have this numerator times this binomial here. So way over here I have 3x plus 3h minus 5 times 2x plus 7 minus, when I multiply here, these cancel, and I have the product of these two polynomials, so that would be 3x minus 5 times 2x plus 2h plus 7, and that's all over. Now I'm not distributing down here, I'm not going to multiply that out, I'm just going to leave it in that form. And again, if you're wondering why, just take my word for it for right now, but when we get to calculus, it's easier to work the problems out that involve this if you do go ahead and leave the expressions as is. If you multiply it all out, it just gets to be a lot messier. Up top, I have some multiplying to do. Binomials times trinomials, and I have to keep careful with my signs here, but I'm going to do this all in one step. I'm going to multiply through by -1 as I do this. So over here, I'm going to write this binomial times this trinomial. I'm going to write 6x squared plus 6xh minus 10x, and then times the plus 7. So that would be plus 21x plus 21h minus 35. And now I'm going to subtract this product. So that's 6x squared here, and subtract, so that's going to be minus 6x squared. And then that's going to be minus 10x, and a minus sign in front is plus 10x. And then looks like minus 6xh. That looks like that's going to be plus 10h. Careful now. And then minus 21x. And looks like plus 35. And that is all over. What a mess. The quantity, or h times the quantity 2x plus 7 times the quantity 2x plus 2h plus 7. Well, the good news, this simplifies halfway decent. Lots of terms cancel. I have a 6x squared and a minus 6x squared. I have a plus 6xh and a minus 6xh. I have, let's see, a minus 10x and a plus 10x. I have a plus 21x and a minus 21x. I have a minus 35 and a plus 35. Lots of stuff cancels. These don't. That's 31h. 31h. And that's all over h times the quantity 2x plus 7 times the quantity 2x plus 2h plus 7. Well, the h's cancel, top and bottom, as a factor of 1. So that gives me, for a final simplified answer, of 31 all over the quantity 2x plus 7 times the quantity 2x plus 2h plus 7. Well, I hope that when we get to the final exam, we don't find anything quite as messy as this, but since it's on the review, these are good problems to practice, and you should definitely practice on the difference quotient problems.